Okay, so today we're gonna just start off by kind of going over what we did last time about drawing the structures for these chemicals. So I have a formula for you right here. First thing you want to do is you want to count the electrons. Okay, so if you take a look at this guy right here, it's made out of carbon and hydrogen. Okay, so if you look at carbon, we're gonna go to the periodic table and count the boxes to carbon. So carbon is box number 1, 2, 3, 4. So carbon has 4 valence electrons and hydrogen has 1. Okay, so carbon has 4 valence electrons and hydrogen has 1. And since there's 3 hydrogens, it's going to be 3. Okay, and then we just keep going down. Carbon is 4, so we're going to add 4 more. Hydrogen is 1, so we add 2 here. Carbon is 4. And then the last one is hydrogen. Okay, so for valence electrons, again, we go to the periodic table. Carbon is 4, hydrogen is 1 each. And so if there's 3 of them, it's 3, 2, 3. And so we just add them all up, and that's going to give us a total of 20 electrons that we're going to draw. Okay, so in our picture, we need to have 20 valence electrons. Okay, so if you guys remember, if your structure or your formula is split up like this, it tells you what the shape of the molecule is. So on the left side, we're going to have a carbon, and we're going to have 3 hydrogens. In the middle, we're going to have a carbon and 2 hydrogens. And then on the right side, we're going to have a carbon and 3 hydrogens. Okay, so that's what the formula tells us it kind of looks like. And then we just connect everybody together. And then you kind of got your shape already. And if you guys remember, one line, it equals 2 electrons. So if we count up the lines, we have 10 lines. So we've used all 20 electrons. So this is what your molecule looks like. Okay. And that's pretty much it. That's the review from last time. Okay, so if you guys notice, our chemicals are starting to get kind of big, right? So it's getting a little bit more and more annoying to draw with all these lines. And so we're actually going to simplify it even more. And that's what we're going to be learning how to draw today. So we're going to be drawing something called a skeletal structure. And there are 3 rules that you guys want to keep in mind. So you're going to want to jot these down on your paper. I'm going to keep this example because we're going to be drawing the skeletal structure for our warm-up. Okay, the first thing we want to do when we draw our skeletal structure is you want to replace all the carbons with corners. Okay, that's the first thing you want to do. All your carbons want to turn into corners. Okay, and I'll talk about what corners means in just a second. It'll be easier once we do the actual structure. Okay, the second thing we want to do is we're going to ignore all the hydrogens that are connected to carbon. Okay, if there's a hydrogen connected to carbon, we're going to ignore it. Okay, and then that just means that if hydrogen is connected to something else, we still need to draw it. And again, it'll make more sense as we go through it. And then you just want to make sure you draw all the other atoms. So those are the 3 rules. I'll give you guys about 2 minutes to copy all that down, and then we will use the chemical structure that we did for the warm-up in order to draw a skeletal structure. And I think you guys will like it because it'll make your lives a lot easier. Okay, guys, so let's take a look right here at the structure. So we're just going to follow the rules. So we're going to replace all the carbons with corners. What that means is we're going to be drawing lines, and every single corner that you make, every point you make is a carbon. So if you take a look here, how many carbons do we have in this structure? 3. Yeah, there's 1, 2, 3. Okay, so all we're going to do is we're going to draw these diagonal lines and make sure that we have 3 corners. So this one will be our first corner. So corner 1, corner 2, corner 3. Okay, so if you guys notice, there's 1 corner, there's 2 corners, there's 3 corners. So that's the shape that you want to make. Okay, so again, there are 3 carbons, so we're going to make 3 corners. Okay, so that's step 1. Okay, hopefully not too bad. And then we're gonna ignore all the hydrogens that are bonded to carbon. So if you look at all the hydrogens, they're all connected to carbon, right? So we don't need to draw them. Okay, what that means is we drew our structure. So this big complicated thing right here, we can draw it like this, and that's our answer. This is the skeletal structure. So a lot easier to work with, right? And so as you guys take a look at the list of chemicals that you can research for your final, they're gonna get really big. So drawing it like this, the way that we used to do it, it'll take too long. So we're gonna be doing it more the skeletal structure. That'll make it a lot easier to draw, okay? And we'll do some practice before I get you started on your assignment and we look at the stuff for your final. Okay. All right, any questions? Oh, and one quick thing before we move on. This works, or you can do it the other way. So if you want to go down instead of up, you can go down. It's the same thing. You're just kind of flipping it. The point is, you're not going to get it marked wrong if you go down first. Doesn't really matter as long as you make the correct amount of corners, okay? All right, let's do some more examples. So you guys don't need to copy this big thing down right here. We're going to go through it together. We're just going to show how we could turn this into that easy skeletal structure, okay? So what we're going to do is we're going to look at the carbons, because if you look at all the hydrogens, they're all connected to carbon, right? And we can ignore all the hydrogens that are connected to carbon. So we can ignore all these H's. We just need to look at the C's. So this is the first carbon right here on the top. So we got a corner on the top. And then it goes down to the right to another carbon. So we're going to go down right there. So carbon 1 goes to carbon 2. And then it goes down from there to carbon 3. So we're going to go down to 3. It's going to go down again to carbon number 4. So if you guys notice, we're literally just tracing what the molecule looks like. We're just following the carbons. And then we go up to the left to carbon 5. And then carbon 6. And then we're just going to close the shape like that. And so this big old ugly chemical right here, this structure, we can draw it very easily like this. This is the same thing as that. Okay, all we're doing is turning the carbons into corners, and then we're ignoring the hydrogens. And if you always want to check your work, you can just count how many corners you got. 1, 2, 3, 4, 5, 6. And there you go. You should have 6 carbons. Okay, so you don't have to count the corners on your skeletal structure. You don't need these numbers. But if it helps you get the right answer, then I do recommend doing it just so it's easier for you. Okay. All right, you guys ready to move on to the next one? Okay, let's go on to one that's a little bit trickier. Okay, because it's not going to stay this easy all the time. Okay, so this one right here looks a little bit more complicated. If you notice, we have different elements. We got a nitrogen, we got some oxygen. So we just need to be aware of those and just draw them normally, okay? So let's start with the carbon. So if you guys remember, if a hydrogen is connected to carbon, that means we can ignore it, okay? So if you have an H connected to a carbon, you ignore it. So we're going to start with this carbon. We'll call it carbon 1. And this carbon 1 is connected to carbon 2. So we're going to draw a line so that it connects from 1 to 2. And I'm just going to label it so that, I know my numbers. Okay, so let's take a look at carbon 2 right here. Carbon 2 has a carbon going up. So we're going to go up. And since it's a carbon, we're going to make it a corner. So we'll call this carbon 3. Okay. So this is our third carbon. Okay. Now, if you take a look at carbon 3, it's connected to a nitrogen, right? And so since it's connected to something that's not carbon, we're going to just draw a line going out. And we have to write nitrogen at the very end, just to show that this carbon 3, the third one right here, is connected to nitrogen. So we're going to connect it like that. Okay, so if you notice again, we're literally just tracing what's up here. We're just turning the carbons into corners and ignoring the hydrogens. Okay, so we finished the end of that line, right? We stopped right there. So let's go backwards to carbon 2. So right here. Carbon 2, if you go to the side, it connects to another carbon. So let's go to the side. And we'll call this guy right here carbon 4. Okay, so carbon 4. Okay. Carbon 4, if you guys notice, if you go down, it's connected to an oxygen. So we have to draw oxygen because it's not carbon. Okay. But carbon 4 also has oxygen on the right side. So we got to draw a line, and we're going to draw oxygen. Okay. And then last thing we do is this oxygen right here is connected to carbon, another carbon. We'll call this guy 5. And so there you go. That's going to be the end of your structure. And since these hydrogens are connected to carbon, we can ignore those guys. And so that's what you'll have right there. And again, you don't have to write these numbers. It's just there for you guys to kind of check your answers. But this is this right here. Okay. So again, when in doubt, just trace the molecule that you got. Just go counting the carbons. Okay. Alrighty, we got one more example. Do you guys think you could try it on your own? Yes? Okay. All right, let's do the last one together. And again, if you don't get one of these, if I go a little too quickly, again, this is posted on Canvas, so you can go back and check it out. Okay, last one. So this is what meth looks like. This is the chemical structure for meth, the drug, right? Since you guys always ask about Breaking Bad and things like that. So I'll give you guys about 3 minutes. See if you can draw the skeletal structure for meth. One thing I didn't tell you about is double bonds. Double bonds, you just draw 2 lines between the corners. Okay, so same thing, just count the carbons, see if you can draw the skeletal structure for meth right here, okay? So take about 3 minutes to do that, and then we'll go over it, and then we'll be all done. Okay, guys, so let's look at this structure right here. So if you guys notice, there are 6 carbons in this ring right here. Pretty similar to one of the examples we did earlier. So you got to make a ring or hexagon of carbons, just like that. Okay, hopefully everyone got that. Now, I said earlier that if there's double bonds, you just draw 2 lines. So between 1 and 6 right here on the top left corner, there's a double bond. So we just need to make sure we draw 2 lines like this. And same thing right here on the bottom left. And then right here on the right side, we draw a line. So if you guys notice, exact same thing that's right here. We're just basically tracing it over. Okay, and I'll try to make it a little bit neater for you guys. All right, now if you guys take a look at this carbon right here, carbon 3, the one on the bottom right, it connects to another carbon here. So we're going to do that. We're just going to make a line stick out. Okay, we'll call this guy carbon 7. And then carbon 7 continues to change. So we draw 1 more carbon going up like that. This one right here, carbon 8, it has a carbon going up. So we're going to draw a line going up. And if you notice, it connects to a nitrogen right here on the right side. So we got to connect it to a nitrogen. Okay, now this nitrogen has a hydrogen next to it. So since this hydrogen is connected to a nitrogen, we need to write this guy down too. Okay, so that's a key thing I want you guys to keep in mind. You only ignore, okay, so you only ignore hydrogens bonded to carbon. Okay, if it's connected to something else, we still need to draw it. So if you miss that, that's okay. I didn't mention that too specifically, so just keep an eye out for that. And then we got 1 final carbon right here on the right side, so we draw a line. And so if you got something very close to this, then you're in pretty good shape. That's what the skeletal structure for meth looks like.